Alright, so after we have learned all about radicals, we can finally go ahead and start learning about quadratics. So today we're going to introduce you to the first way to solve all quadratic equations. Well, most of them. And that is by, completing the square. So I'm sure you've heard about this in grade 10. But we are going to go through it today again. So I just wanted to go ahead and give you a little bit of formatting before we start. So, right here in question number 1, we have y equals 4x squared minus 24x plus 31. If you do not remember, this was the standard form. Standard form. So everything is written out, no brackets, no nothing. This is the standard form with the highest degree constant on the very left, all the way to a regular number on the right. Now, when we have something in the form of y equals a bracket x minus h squared plus k, this is called a vertex form. So basically, when you are going to have your vertex at hk, this is a vertex form. And really, this is going to be our result when we do complete the square. We're going to essentially get the vertex form. So let's go ahead and actually just start on these questions. Okay. So when we do complete the square, we're going to first factor so that our x is going to be, well, a single x. So we cannot have a complex trinomial. We have to have a simple trinomial. So in this case, we're actually going to factor only out of the first two variables. So we're going to do this. And now we are already halfway done this. So let's go ahead and actually just complete the square. So what do we do to complete the square? So we're going to divide the middle term, which is this term. Divide the term with x to the first power. So this term right here. We're going to divide it by 2. And then we're going to square it. So this is going to go ahead and give us negative 3 squared, which is equal to 9. So now what we're going to do is we're going to do 4x squared minus 6 plus 9. However, to add a 9 in here, we also have to minus a 9. Minus a 9 in here. So because we can't just add random things into the bracket. That's not how it works. That's not how math works. So if we want to add a 9 in here, we're going to minus a 9. And you will see why it's going to be 9 very soon. So now, if we want to take the 9 out of the bracket, we have to multiply it by 4 first. So that's going to be negative 36 minus 36. So we can go ahead and get rid of the 9 now, but this is going to be minus 36 outside plus 31 because that's just right there. Now, you might look at this middle in the bracket and you're going to be like, oh, look, this seems very familiar. What is this? A perfect square. And then on the right, we can go ahead and gather all of these like terms. That's going to be negative, 5. So what is this? This was the vertex form that I mentioned earlier. So what is our vertex right now? 3 and negative 5. And now, since the question asks for the minimum value, we actually know the minimum value. Because whenever we find the vertex of a quadratic, when the first term is positive, so the first term is positive means we're opening up. So when we find the vertex, we're always finding the minimum. So now we know our minimum is actually 5. And that happens when x equals 3. So we went ahead and find the vertex using the completing the square. Now let's go ahead and complete the square for a fraction one. So, as usual, we're going to go ahead and write. So since when we try our best to create this perfect square trinomial, we usually want the x to be a single term. So no negatives here. So we can factor a 0.3 out. So 2.4, when you divide that by 0.3, you're going to go ahead and get 8. So you're going to get x squared. And remember, you factor out negative, so the negative's gone. It's going to be plus 8 now. And now we do the same thing again. So 8 divided by 2 squared, that's going to give you 16. So we're going to do plus 16. And then now let's look at what? Minus 16. So we also have to minus the 16, by the way. But I was just trying to skip that step. So minus 16, to get it out of the bracket, you're going to times that by, well, negative 0.3. So 16 times 0.3, that's going to give you 4.8. So 4.8. And because it was a negative, and this was a negative too, so it's plus 4.8, and then that's plus 7.3. So now if we gather all the like terms, this is going to be 0.3, and this is going to be x plus 4 squared plus 4.8 plus 7.3, that is 12.1. So go ahead, we'll have our vertex of -4, -4, and 12.1. And that is our answer. So our maximum value right here is 12.1. Whenever you find the vertex, you're always going to find either the max or the min, simply because, well, simply because that's just the vertex. That's the highest point or the lowest point. And if you can understand whether you're finding max or min by looking at the first term to see if it was positive or negative. So back in grade 10 you learned if this was negative, it opens down. If it was positive, you open up. And that was pretty much it. And now let's go ahead and do example 3. So maximum value of the function 5x minus 3x squared. So now, what happens when we have this, well, this messed up function that do not have a third value and it's completely messed up, and when we factor it's going to be fraction? Well, it's no different. So first let's arrange it, because I don't like this. This doesn't look good. We're going to go ahead and clean it up so we have the highest degree on the left. So now we're going to factor out a -3. It's going to become x squared minus, remember we're taking out a positive, so this is going to be minus 5 over 3x. And now you look at it and be like, oh no, oh crap, that is a decimal value. That's not good. So 5 over 3, we have to divide that by 2, which is time 1/2. So that's going to go ahead and be 5 over 6. And this squared is going to give you plus 25 over 36. And now we have to minus the 25 plus 25 36 as well. Minus 25 over 36. And now, since we don't have anything outside the bracket, there should be no collection of terms outside the bracket, but we still have to get this out of the bracket, or else we can't factor this. So we're going to be like, oh, okay, 25 times 3, that is negative. So we're going to go ahead and be like 25 times 3. Oh, crap, that's 75. So plus 75 over 36. Look at it. Can this be simplified? Yes, it can be divided by, what, 3? And then 25 over 12. And then now, all we have to do is just simplify it in the middle. So -3x squared minus 5 over 6 squared. So remember, the end term you're going to have here, this is always going to be the middle term that we had before, divided by 2. Just so you know. And now, plus 25, 12. So our vertex is going to go ahead and be 5 over 6, 25 over 12. And that is our maximum point. Yep, maximum value is 25 over 12 and 5 over 6. So for all of these questions, we're always getting asked the maximum value, minimum value, maximum value, all of this. So all we have to do is actually give out the number. So just for this one, it was 25 over 36, over 12 or something. So we only have to give out this, because that's the actual height. That's the actual value. However, when it asks for your max point, you will have to give both the x and y, because this is actually a definite point. It's a coordinate. So make sure to actually read, which I know a lot of people don't do. I didn't do it back then, and I learned that a hard way by losing a ton of marks. So please, guys, read. Now let's go on to 4. It's a simple word problem, but this is kind of more of the logic side, where you have to use your brain and think a little bit. So let's go ahead and look at that. So we have, find the minimum product of two numbers whose difference is 8. So, difference is 8. So, let's see. So, basically, when you have the minimum product, okay. So, let one number be, let's say, x. And then the other number is going to be x plus 8. So, x and x plus 8. The product of these two numbers are going to be, well, we're trying to minimize the product, I guess. So, what is the product? It's the thing after, well, it's the answer that they get after they get multiplied together. So that's going to go ahead and be x squared plus 8x. Now, since this is a positive, so, well, this is positive, we know that it opens upwards, right? So now, when we find the vertex of this, we're always going to get the minimum point. So we're going to always be optimizing, well, the thing that we want to optimize. So because we want to find the minimum point, right? So we're always going to find the minimum point. So let's go ahead and be like, let's go ahead and complete the square. There's many different ways you can solve this, but for now, we're going to complete the square. So to complete the square, we're going to be like x squared plus 8x, and then 8 divided by 2, which is 4 squared plus 16, and then minus 16, and then we're like looking at this, and then that's going to be x plus 4 squared minus 16. So now we can see negative 4 and 16. So, since we don't really need to care about this, all we have to care about is the minimum product. So right here, our minimum product is 16. So that is the y value. Because remember, when we find the x value, that is the numbers. They didn't ask for us for the numbers, they only asked us for the values. So we give out 16 as the answer. Now, when you get into like calculus, you can go ahead and be like x squared plus ax, and then you take the derivative of that, which is 2x plus 8, and now you just make this 0, and that's just x equals negative 4, and then you plug that back in, which is 16 minus 30. Well, okay, yeah, and then you do that, and then you will get the value. So essentially, all the times we're going to be able to get a value, and, well, just I wanted to show you that because I just wanted to let you know that unless you're doing something wrong, all different methods should lead to the same, well, same answer. Now let's look at this. So this is a typical question where it asks us to optimize. So the student council plans to run an annual ticket show to raise money for the charity. Last year tickets sold for $11 each. So 111, I'll write that. 400 people bought it. So 400 people bought the ticket. So this was the revenue last year. The student council decided to raise the tickets prices, and then we determined that every dollar increase is every $1 increase, there's gonna be 20 people decrease. What ticket price would be the max? What ticket price do we need to maximize value? Okay, so usually for these questions, we'll let a variable. Let's say I want x. So I want let x be the number of price changes. So you write the let statement, that is 1 mark. And then after you write the let statement, let's build the equation. So $11 was the price. So plus for every $11, whenever we add $1 increase, so plus x, our revenue, this is our revenue function by the way. And the people that attended, which is 400, it will go down by 20 for every time that we will change the price. So here's that. So 11 plus 1, because it increases by $1 every increase, and 400 minus 20, because it will decrease by 20 every time the price increases. So we're going to go ahead and actually multiply this out. It's just a simple question. So 400 times 11, that is 4400, and then minus 220x plus 400x minus 20x squared. And then you can go ahead and solve this. So I will put the negative 20x squared here, and then I'll collect the like terms. So negative 220 plus 400, that is going to go ahead and give us 180. And plus 4400. And then we're going to go ahead and factor this. So negative 20, and then I'll just give you the answer right away because we don't have enough space right here. So after you factor out negative 20, that's going to be a 9. So x, well, we can directly know it's x plus 4.5 because we divided by 2. And I taught you a little earlier that if we just do the middle term divided by 2, that is going to be what we have. So now you may be questioning, hey, why is this? This is because you had a negative 9 here. You factored out the positive. So we have 4.5 squared. And now we just have to determine this, which is 4805. I'll write that for you. So finally, the x will be 4.5. And then the people that chooses to attend, well, we can't figure that out, but we will figure out the amount of revenue that we will earn, which is 4805. So that is the amount of money we will earn. However, note, when we set it back here, when we wrote our let statement, 4.5 is not the price. It's the amount of times that we changed, or to say we increased our price. So now we actually have to find the price. So 11 plus x was 4.5. This is going to go ahead and give us $15.5. So at $15.5, we will earn $4,805. 4,805, and we'll have that amount. We'll have a people amount that attend. Well, okay, I will just write that out. So 400 minus 20 times 4.5. That's going to be 90. So 490. So that's going to be 310. So at the price of $15.5, we'll have 310 people attending, and that will make us $4,805, and that is how we maximize the value. So I don't believe I didn't add any practice questions for this class simply because I realized, hey, you should know this already. So if you don't, make sure to comment down below or email me whenever you feel like.